Good day and welcome to Gifted and Science and Technology class. We'll be looking at thermophysics today, and under thermophysics, we'll be looking at various subheadings, but we'll be starting with what is temperature. Temperature is the degree of hotness or coldness of an object or a body. Now, apart from that definition, another important definition you have to know about temperature is that it is the average measure of the kinetic energy of a substance or an object. Take note, is an average measure, but heat is the total measure of it. So one of the differences between temperature and heat is that temperature is an average measure of the kinetic energy, but heat is the total measure of the kinetic energy of the substance or the body. What about our temperature? The SI unit for temperature is either we're using degrees Celsius or Kelvin, although the standard is Kelvin. Now take note, temperature first is a fundamental quantity. We have what we call fundamental quantities. Those are quantities that all other quantities depends on. So temperature is a fundamental quantity, and also it is a scalar quantity. Temperature is a fundamental quantity, it is a scalar quantity. It is measured using the thermometer. Now, temperature being measured using the thermometer. So the thermometer is a device used for measuring temperature. And now we have a thermometer has a thermometric substance whose property changes with the change in temperature, either the rise or fall in temperature. So in every thermometer, you have a substance in them which enables us to measure temperature. And these substances are called thermometric substances. Now, these substances are what helps us to break thermometer into various kinds. So the first one we have the liquid in glass thermometer. So it means in this thermometer, there is a liquid, and we have two types of liquid in glass thermometer. We have one, the clinical thermometer, then we have two, the maximum minimum thermometer, also called the 6 thermometer. So these two thermometers are example of the liquid in glass thermometer. Now, what do you have in the liquid in glass thermometer? You have mercury or alcohol. That's the liquid we have in them. We'll look at the preference of one over the other. Why is mercury preferred over alcohol in a clinical thermometer, and why is alcohol preferred over mercury in some other thermometers? Now, we have the physical property that a thermometer, that a liquid in glass thermometer, such as the clinical thermometer and the 6 thermometer uses to function, is that the liquid in the thermometer changes with temperature. So when there is an increase in temperature, the liquid rises. When there's a decrease in temperature, the liquid contracts. So the changes in temperature determines the volume of the liquid. We have another one which is called the gas thermometer. In the gas thermometer, we have two types, which is the constant volume gas thermometer and the constant pressure gas thermometer. What is a thermometric liquid in this thermometer? Is a gas. An example of such gas we have in this thermometer is helium. Now, what is the physical property of this thermometer? Now, take note, for the constant volume gas thermometer, it works in the property of gas pressure changes with temperature. Now, take note, volume is constant, therefore the gas pressure changes with temperature. Look at the second one, constant pressure gas thermometer. Now, what does it work on? It works on volume of the gas changes with temperature. So when the volume is constant, pressure changes with temperature. Then when pressure is constant, volume changes with temperature. So this is a gas thermometer. And take note, the gas thermometer is more accurate and sensitive than the liquid in glass thermometer. Take note again, the gas thermometer is also called an absolute thermometer, and it measures more accurately than the liquid in glass thermometer. Now we have another one which is called the resistance thermometer. In the resistance thermometer, what do you have in as the thermometric property? You have the resistance wire. Now what happens, how does this function? It functions with resistance changes with temperature. Resistance changes with temperature. So actually in a wire, when the temperature increases, the resistance increases also. So resistance changes with temperature. Now we have another one here, which is called the thermocouple. The thermocouple functions under an effect called the Seebeck effect. Now, what about it? it functions with a thermometric property of two different mentals. Now, if you look up, you see a picture here, two different mentals, silver wire and copper wire, placed at two different junctions. Two different mentals placed at two different junctions of different temperature. This is ice and this is water, boiling water. Now, the differences of this junction or the different differences at this junction will result to a release of electric current in this circuit. Now we have this converting heat energy to electrical energy. That's all about the thermocouple. The thermocouple is a device that helps to convert heat energy to electrical energy, and that process or that effect is called Seebeck effect. But there is also something that helps to convert electrical energy back to heat energy. That effect is called the Plater's effect. The Plater's effect. Take note of this. This is converting electrical to heat energy. And a good example of something that functions here is your refrigerator. The refrigerator works on this principle, but Seebeck effect is for the thermocouple, which converts heat energy to electrical energy. Now we have another kind of thermometer called the bimetallic thermometer. This thermometer consists of two different mentals of different expansion. So what is the thermometric property that it works on? It works on length or expansion changes with temperature. So we'll come here, it's a full topic, we're going to discuss this, but note that there's a thermometer called the bimetallic thermometer, and there's another one called the pyrometer. That's another kind of thermometer that use radiation to function. Now remember I told you about the property or the substance in a thermometer that we call thermometric substance. And this substance must have a particular property that makes them suitable as thermometric properties or thermometric substance. Now, what are these properties? One, it will have a high thermal conductivity, meaning it is a good conductor of heat. So for a substance to be a thermometric substance, it must have a high thermal conductivity. Another one is a high coefficient of expansion, and in quotes, it must expand uniformly. So if we say that in the difference of 20 degrees Celsius, this is what is expanding. In the next 20 degrees Celsius, it should be a uniform expansion, not an irregular or a ununiform expansion. It's very important. Now we have another one, good opacity. That means it's a colored liquid or it is something that is not transparent. Then we have another one, high boiling point. In order for it to be able to measure a temperature of a high boiling point, it must have a high boiling point also, and also a low melting point. So a good thermometric property should have all of these. Then we have number five, it should have a low heat capacity or a low specific heat capacity. What does that mean? It means that a small amount of heat should be able to raise a good noticeable temperature. So a small amount of heat can be able to show a rise in temperature. So that is what we call a low heat capacity. Now take note, these are some of the properties that mercury has over alcohol as a liquid in glass thermometer. You see a question like, why is mercury more preferred over alcohol? Some of the reasons is that mercury is a good conductor of heat over than compared to alcohol. Mercury has a high boiling point. Mercury has a good opacity. Alcohol is transparent, but mercury is opaque. It's more of like a silver color. So it has a uniform expansion and it has a low specific heat capacity. These are the importance. One importance that or one property that alcohol has over mercury is that alcohol expands more than mercury. The expansion of alcohol is 6 times that of mercury. And another thing is that alcohol has a more lower melting point than mercury. So these are some of the properties that alcohol has over mercury, while mercury has more of the properties of a good thermometric substance over alcohol. Now we'll be looking at temperature scale. In temperature scale, a scale or a thermometer scale precisely it's used to measure temperature. Now it has the upper fixed point and the lower fixed point. A temperature scale has the upper fixed point and the lower fixed point. Now, what is the upper fixed point also called? It's also called the point of boiling steam. It's also called the point of boiling steam. While the lower fixed point is also called the point of melting ice. How do you determine an upper fixed point? You determine an upper fixed point using what we call an hypsometer. Hypsometer. It's the instrument that or the device used for measuring the upper fixed point of a thermometer. What about the lower fixed point of a thermometer? You can determine that by putting a thermometer in a glass eyes. You have eyes, then you have a thermometer placed into the eyes. That's an experiment to determine the lower fixed point of a thermometer. Now look at this. The difference between the upper fixed point and the lower fixed point will definitely become the gap between the upper fixed point and the lower fixed point, and we call that the fundamental interval. So the fundamental interval is upper fixed point minus lower fixed point. So for instance, look at a Celsius scale. This is a Celsius scale. You have the upper fixed point to be 100 degrees Celsius and the lower fixed point to be 0 degrees Celsius. So the difference between the upper fixed point and the lower fixed point, which is 100 minus 0, is 100. So the fundamental interval in a Celsius scale is 100. This is a Fahrenheit scale. The upper fixed point, which is the point of boiling steam, is 212 Fahrenheit, while the lower fixed point is 32 Fahrenheit. So the difference, which is the fundamental interval, is 212 minus 32. I think that's 180. The same thing for the Kelvin scale. For the Kelvin scale, you have the upper fixed point to be 373 and the lower fixed point to be 273. The difference will be 100. That is for the Kelvin scale. Then that's the Rankine scale. You have the upper fixed point to be 672 degrees and you have the lower fixed point to be 492. So all of these are various kinds of of thermometers or various kinds of temperature scale, and the upper fixed point and the lower fixed point. Remember, the upper fixed point is also called the point of boiling steam, while the lower fixed point is called the point of melting ice. Now we're going to look for how these scales can be calculated for when comparing a Celsius scale to a Fahrenheit scale or a Celsius scale to a Kelvin scale. Now let's look at conversion of temperature. Now we have number one, to convert degree Celsius to Kelvin. This is the formula to use. Kelvin equals degree Celsius plus 273. To convert degree Celsius to Fahrenheit, we have C over 5 equals F minus 32 over 9. To convert Fahrenheit to Kelvin, then we have this. Now, it's so amazing to know that all of these things can be gotten. And let me show you how it is. Now, we are converting degree Celsius to Kelvin. So this is the Celsius scale. This is the Kelvin scale. Now, let's assume I want to know what C will be equivalent to as K. Now, 100 is equivalent to 373. 0 is equivalent to 273. Remember, this is lower fixed point, this is lower fixed point, this upper fixed point, this upper fixed point. So I'm not looking at what will this degree Celsius is to this Kelvin. So how will this be now? I want us to look at it this way. I will do something as, let me call this number one, number two, and number three. Let me call this number one, number two, and number three. Now look at what I want to do. I will say let number two minus number three over number one minus number three is equal to, do the same thing here. Number two minus number three over number one minus number three. So put it out in its value. It becomes C minus 0 over 100 minus 0 is equal to K minus 273 over 373 minus 273. So this becomes C over 100 is equal to K minus 273 over 100. 100 takes off 100. What becomes C? I have C is now equals K minus 273. Therefore, what is K? K is now equal to C plus 273. Look at the formula here. That's what I have here. Now let's see how to convert degrees Celsius to Fahrenheit. Now look again. This is the upper fixed point of degrees Celsius. This is the upper fixed point of Fahrenheit scale. This is the lower fixed point of a Celsius scale. This is the lower fixed point of a Fahrenheit scale. Now I want to now check for what C will be equivalent to in a Fahrenheit scale. Remember again, let this be 1, let this be 2, let this be 3, let this be 1, let this be 2, let this be 3. So I will make the move again. 2 minus 3 over 1 minus 3 is equal to the same thing over here. 2 minus 3 over 1 minus 3. So that will now be, put it out in values. It becomes C minus 0 over 100 minus 0 is equal to F minus 32 over 212 minus 32. That becomes C over 100 is equal to F minus 32 over 180. C over 5 is equal to F minus 32 over 9. Look at the formula here. That's the second formula we have here in converting degrees Celsius to Fahrenheit. Now, the same thing is applicable to this. If I do the same thing, I will still arrive at this place. So you try it, how you do it. You remember now a degree Fahrenheit will correspond to a what now? A Kelvin scale. So take here 1, 2, 3. Take here again 1, 2, 3, and do the way we have done these two examples and see yourself arriving here. Now let's look at some examples. Number one, convert 100 degrees Celsius to Kelvin. A very simple solution for number one. I have Kelvin is equal to degrees Celsius plus 273. So Kelvin will be equal to, our degrees Celsius is 100 plus 273. So it means that Kelvin will not be equal to 373. So if you watch, when 100 degrees Celsius is the upper fixed point, in degrees Kelvin, it was 373. Now let's see number two. Question number two, it says convert minus 40 degrees Celsius to Fahrenheit. Which formula are we using? We're using C over 5 is equals F minus 32 over 9. So now we are using minus 40 for degrees Celsius. So I have minus 40 over 5 is equals F minus 32 over 9. This and so this, I have it as 8. So I have minus 8 over 1 is equal to F minus 32 over 9. Minus 8 times 9 is equal to F minus 32. So this becomes minus 72 is equal to F minus 32. So I have F will be equal to minus 72 plus 32. F will now be equal to minus 40 degrees Celsius equals minus 40 Fahrenheit. Minus 40 degrees Celsius equals minus 40 Fahrenheit. So if they ask you at what temperature is the Celsius scale equals the Fahrenheit scale, the answer is minus 40. At what temperature is the Celsius scale equal the Fahrenheit scale? The answer is minus 40. Now let's look at question number 3. It says, at what temperature is degree Celsius 5 times degree Fahrenheit? Now this question means that we are looking at the temperature of degree Celsius, not the temperature of Fahrenheit. At what temperature is degree Celsius 5 times the Fahrenheit? So now it means that degree Celsius is equals 5F. Now is how it was spelled out in the question. So if I use the formula C over 5 is equal to F minus 32 over 9. Now you see that if I replace C for 5F, if I replace C for 5F, the only thing that will be appearing in this equation will be F. There will be no C again. So it means that will not be a wrong move, because what I'm to calculate for is actually degrees Celsius. So it means I will now say, therefore, what is now F? F will be equal to C over 5. So I'll be putting, in place of my F, I'll be putting C over 5. That's the only way I can retain degrees Celsius in the calculation. So I will now have C over 5 is equals C over 5 minus 32 over 9. That's how it will be expressed. Now, mind you, I will now go further to say cross multiply. Okay, let's solve this place out. I will not be having, if I'm solving this place out, it will be uh, uh, C 5 times 32, which is 180. 180 times, sorry, which is 160. 160 minus C over 5. Okay, let me solve it out. I'll have it as C over 5 minus 32 over 1. So I have it as 5. 5 minus 5 is 1. Then 1 is C minus this. So this is 5 times this will not be 160. So I'll be having C minus 160 over 5. So everything here is what I have there. So this will not become, so from here, I will not be having 5, sorry, C, 5, C over 5, C over 5 is equal to, so everything here now has now become C minus 160 over 5. Now, what's the next thing? Divide by 9. Divide by 9. So this will now be C over 5 is equal to C minus 160 over 5 times 1 over 9. So I have C over 5 is equal to C minus 160 over 45. So now cross multiply and I have 45C is equal to 5C minus this times this is 0, this times this is 30, 0 carry 3, 5, 6, 7, 8. That's 800. So now take this way. Take this way. You now you have 45C minus 5C is equal to minus 800. So I have this as 40C is equals minus 800. So this cancels out this, and this here too. So C is equals minus 20. So the answer to that question is at what temperature is degree Celsius 5 times degree Fahrenheit? The answer is minus 20 degrees Celsius. Thank you.